The ROV light cuts through absolute darkness, revealing a concrete wall thick with algae. The beam moves slowly along its surface until it stops on a steel door, still mounted in its frame, corroded but intact. Beyond it, the flooded interior of Versuchsraum K-17 opens into a vast assembly hall where the water holds everything in suspension. Prototype chassis rest on their sides, half buried in silt. Work tables stand exactly where they were abandoned. Tools lie scattered across the floor as if the engineers had simply walked away mid-shift and never returned. This facility appears in scattered German military documents from early 1945, referenced under different names. Projekt Eberstahl in some reports, Mechanische Testhalle Süd in others. No photographs survived. No blueprints made it into Allied intelligence files. The complex was flooded deliberately during the final evacuation, sealed off from the retreating Wehrmacht forces, and forgotten until sonar surveys detected the structure beneath what is now a reservoir in southern Germany. What the divers found inside has remained largely undocumented outside military archives. Strange machines that match no known German vehicle classification. Components designed for purposes that remain unclear. A snapshot of experimental work that ended abruptly in March 1945, preserved in cold water and silence. The main assembly hall stretches nearly 40 meters, its ceiling lost in darkness above the reach of the lights. 5 chassis occupy the space, each mounted on steel test rigs that keep them elevated above the floor. The first resembles a Panzer hull, but the proportions are wrong. The turret ring is offset to one side rather than centered. The tracks are wider than standard issue, each link twice the thickness of those used on Tiger tanks. The front glacis plate angles inward at a degree so steep it would compromise internal space, suggesting the designers prioritize deflection over crew compartment size. The second chassis sits partially collapsed, its suspension system exposed. 8 road wheels per side instead of the usual 6. The springs are hydraulic rather than torsion bars, a design the Wehrmacht had tested and largely abandoned by 1943 for reliability issues. Yet here, the system appears refined, with dual cylinders and what looks like an experimental dampening mechanism. The hull shows no provision for a standard engine. The rear compartment, where a Maybach power plant would normally sit, contains only mounting brackets and a complex series of drive shafts leading to nowhere. Further into the hull, a tracked platform bears no resemblance to anything in the German armor catalog. The body is low and flat, barely a meter high, shaped like an elongated hexagon. No turret, no gun mount, no crew hatches. Just a smooth upper surface, broken by 4 circular apertures, each about 30 centimeters across. Beneath the chassis, the running gear uses small road wheels in a staggered pattern, 16 per side, suggesting this machine was designed to distribute weight across soft ground or rough terrain. The purpose remains unclear. The size is wrong for a remote-controlled demolition vehicle. The shape offers no tactical advantage for a reconnaissance platform. Against the far wall, 2 more prototypes sit side by side. Both feature unusual wheel configurations. 6 wheels arranged in a triangular cluster on each corner, with independent suspension arms connecting them to the hull. The steering mechanism appears to allow each wheel cluster to rotate independently, potentially enabling the vehicle to move in any direction without turning. One chassis shows evidence of amphibious modifications: sealed lower hull, a propeller shaft extending from the rear, and what appear to be retractable rudders. The other has been stripped down to its frame, every panel removed, exposing the internal structure and the mounting points for systems that were never installed. A corridor branches off from the main hall, its walls lined with industrial shelving units that rise 3 meters high. The shelves hold hundreds of components, each coated in rust and sediment, but still recognizable. Gearbox assemblies that don't match standard transmission designs. Hydraulic cylinders marked with pressure ratings far exceeding those used in contemporary German vehicles. Drive sprockets with tooth patterns that suggest they were meant for tracks of unusual width or pitch. One shelf contains nothing but turret mechanisms, but these two deviate from known patterns. The ring bearings are massive, designed for loads heavier than any German tank turret from the war. The traverse gears incorporate electric motors rather than manual hand cranks, a feature only the late war Panther AUSF. F was supposed to receive, and even that remained largely theoretical. Several mechanisms show dual-speed systems, allowing both rapid traverse for close combat and fine adjustment for long-range targeting. Another section holds suspension components arranged by type. Torsion bars of varying lengths and diameters. Leaf springs that appear to be steel alloy rather than standard carbon steel. Experimental shock absorbers with adjustable damping, each unit marked with cryptic designation codes, HSF7, RWD14, KPL22, that appear in no surviving Wehrmacht coding system. Some components show signs of testing, stress fractures, deformation under load, witness marks where measurement devices had been attached. The far end of the corridor opens into a smaller room dedicated entirely to what appear to be propulsion experiments. A workbench holds 3 different engine configurations, all stripped to their core components. One is clearly a diesel, but the cylinder arrangement forms a W pattern rather than the standard inline or V configuration. Another uses opposed pistons, a design the Junkers Jumo aircraft engines employed, but never appeared in German ground vehicles. The third engine defies easy classification. Its crankcase suggests a rotary design, but the combustion chamber layout indicates it operated on principles not used in production engines of the era. Individual work areas occupy alcoves along the main corridor, each one frozen exactly as it was left. The first station contains a drafting table with technical drawings still pinned to its surface. The paper dissolved into a gray pulp, but the graphite lines still faintly visible beneath the preservation layer. The drawings show a vehicle profile unlike anything in the German inventory, a hull shape that tapers dramatically from front to rear. With a turret positioned so far forward, it would create severe balance issues unless the rear compartment carried enormous weight. Tools remain arranged on shadow boards, their silhouettes marked in paint to show proper placement. Precision calipers, micrometers, torque wrenches calibrated to specific values. Some tools show modification, filed and reshaped for purposes that aren't immediately apparent. A set of wrenches has had their heads bent at precise angles, suggesting they were custom-made to reach fasteners in confined spaces within prototype assemblies. The next station holds what appears to be an electrical testing setup. Cables drape from overhead conduits, their ends connected to a panel board covered in gauges and switches. The panel shows voltage and amperage meters, their needles still pointing to 0. Below the bench, storage drawers contain vacuum tubes, resistors, capacitors, and wire wound into careful coils. One drawer holds nothing but fuses, dozens of them, many showing evidence of having blown during testing. The burn patterns on the fuse elements suggest the system drew far more current than standard Wehrmacht electrical systems, which typically operated at 12 or 24 volts. Further down, a welding station stands ready for work that never resumed. Gas cylinders sit chained to the wall, their regulators still set to working pressure. Electrode holders lie on the bench, their copper contacts worn smooth from use. Metal samples cover the work surface, test welds joining different alloys, each one labeled with numbers that presumably corresponded to a logbook that is no longer present. Some welds show clean, uniform penetration. Others display obvious defects: porosity, incomplete fusion, cracks along the heat-affected zone. These were learning experiments, attempts to join materials that standard welding procedures couldn't handle. The last station contains nothing but paperwork storage. Metal filing cabinets line the walls, their drawers pulled halfway open as if someone had been searching through them during the evacuation. Most documents have disintegrated into pulp, but a few pages sealed in waxed paper sleeves remain partially legible. They show material requisition forms, testing schedules, and equipment transfer orders. One sheet lists delivery dates for components that never arrived. The final entries dated March 7, 1945, just weeks before the facility was abandoned. The corridor descends, leading to a lower level where the ceiling height increases dramatically. This section was designed for larger assemblies. 3 substantial prototypes occupy the space, each one representing a different approach to mobile platform design. The first is unmistakably a tracked vehicle, but its scale is wrong for a tank. The hull measures nearly 12 meters long, far exceeding even the Jag Tiger. The tracks are correspondingly massive, each link weighing what must be close to 50 kilograms. The suspension uses external bogies rather than the internal system German tanks employed, and the number of road wheels, 24 per side, suggests this machine was designed to distribute extraordinary weight. The upper hull shows mounting provisions for something, but whatever was meant to sit there was never installed. Only the bolt patterns and reinforcement ribs remain, offering no clear indication of purpose. Beside it rests what can only be described as an amphibious chassis. The hull is boat-shaped, with a pronounced bow and stern. The sides angle outward above the waterline, then curve back inward below it, creating a shape that would provide stability in water while maintaining a narrow ground footprint. The propulsion system uses twin screws at the rear, driven by shafts that connect to a transmission mounted amidships. On land, the vehicle would move on tracks, but these tracks are unusual, segmented into short sections that appear designed to fold or articulate, possibly to reduce water resistance during swimming operations. The third prototype is the most perplexing. It sits on 6 large wheels, each one nearly 2 meters in diameter, with pneumatic tires that have long since rotted away, leaving only the steel rims. The chassis between the wheels is minimal, just a framework of heavy I-beams welded into a rigid structure. The entire assembly appears designed to carry a single large load on its upper surface, but that load is absent. What remains are the mounting points, massive bolts set into reinforced bosses, and a series of clamps and tie-downs that suggest whatever this vehicle carried needed to be secured against significant movement. Against the wall, partially buried in silt, several smaller tracked platforms show evidence of remote control systems. Cables snake from compartments in their hulls to junction boxes mounted externally. These cables are too heavy to be standard electrical wiring. They're armored and shielded, suggesting they carried either high voltage power or signals that needed protection from interference. One platform has a small turret, but it mounts no gun. Instead, the turret contains what appears to be an optical system. Lenses, prisms, and mirrors arranged in a configuration that doesn't match any known German tank site.